Hello, welcome to lesson 2 of the Insight LSAT mini LSAT prep course. In this lesson, we're going to be talking about the basics of LSAT logic. In many ways, you could say that the LSAT is a test of your logical abilities, right? It tests your ability to think logically, to understand arguments, and to understand when certain statements follow from other statements. So it's really important to understand what logic is and how it's used on the LSAT. That's a picture of Aristotle there. He's a philosopher who is known as the one who laid down the foundations of a lot of what we talk about when we talk about logic today. Logic is the driving force behind argumentation. It is a way of explaining why some statements can combine with other statements to lead to even further statements. For example, take a look at these two statements here. Socrates is a man, and all men are mortal. Now, this is a very famous argument that is used to demonstrate logical flow or logical consequence. Take a look at that second statement for a minute. All men are mortal. This statement tells us that there's a certain category, men, and that every member who fits into that category has a certain property, being mortal. Now, that first statement, Socrates is a man, that just tells us that Socrates is one of the items that fits into the category of men. So, if all men are mortal and Socrates is a man, what can we conclude from the combination of these statements? When I use the symbol here, it's going to represent therefore or consequently. It's going to be kind of like an equals sign if we were doing math, but it's a logical equal sign. So right, these two things together lead to, logically, the following statement. And I hope you guessed it already. Socrates is mortal. Now there's a technical, almost mathematical background to logic, and it's far too technical to deal with here, and you don't need it for the LSAT. But actually, logic is kind of like math, and there are rules that explain all different aspects of it and explain more precisely why it is that Socrates is a man and all men are mortal leads to Socrates is mortal. But we really don't need to get into that here, and you don't need to get into that at all to do well on the LSAT. I just want you to start to get a feel for logical consequence and thinking logically, and it's represented very clearly in this basic argument here. And going forward, we're going to refer to the statements that are above our therefore or equal sign as premises, and we're going to refer to the statement below it as a conclusion. And the premises will be support for the conclusion. The premises will lead to the conclusion. Now, of course, when you're dealing with logic on the LSAT, or pretty much anywhere else in the world, it's not going to be as clear-cut as the example we just used. The logical structure is going to be lying behind a regular textual structure. There's going to be logic embedded in regular-looking text, and you're going to need to pull that out and understand it. You're going to have to find the conclusion, find the premises, and understand how they go together, if they go together. Sometimes, and often on the LSAT, there'll be a mismatch between the premises and the conclusions. That'll be a bad argument, and you have to point that out. But let's take a look at a fairly simple example. The town should not raise taxes in order to pay for new high school textbooks. The town should only raise taxes to pay for things that can be used by all citizens, and high school textbooks can only be used by some citizens. Let's take a look at the logical structure of this paragraph. It's in a different order than the regular structure of the paragraph. The premises are kind of similar to what we did last time. There's a general rule. The town should only raise taxes to pay for things, right, general language, that can be used by all citizens. The next premise, high school textbooks can only be used by some citizens, right? That statement tells us that high school textbooks don't fit into the category described in the first statement. Therefore, the town should not raise taxes in order to pay for new high school textbooks. This last statement is the conclusion of the mini argument we have here, and these other two statements lead up to it. It's important that you see how that happens. The key to understanding logical structure and to determining logical structure from a regular piece of text is to start by finding the conclusion. If you can figure out what everything else in the little blurb is leading to, you can work backward from the conclusion to understand how the other statements relate to it and how they support it. So go ahead and try it here. Take a look at this short blurb and try to find the conclusion. You want to look for the statement in the little blurb that everything else leads up to. This is a good time to pause the video. In a moment, I'll go ahead and point out the conclusion for you. Alright, I hope you found it. Let's read the blurb. I thought Michael was my friend, but I just found out he has been lying to me for the past year. Someone who lies to you cannot be your friend, so obviously Michael is not my friend. Everything in this statement is leading up to this last bit right here. So obviously Michael is not my friend. The other statements, I thought Michael was my friend, that's just kind of background. I just found out he's been lying to me, and someone who lies to you cannot be your friend. Those two statements combine to give us our conclusion. But the conclusion here is the one that ends the little blurb. Obviously, Michael is not my friend. So far, we've seen conclusions at the beginning of paragraphs and at the end of paragraphs. Let's try to find it in this one. The LSAT is the most important part of your application package for law school. Your score could earn you tens or even hundreds of thousands of dollars in scholarship money. Time spent practicing LSAT questions is thus time well spent. Practicing LSAT questions is an effective way of improving your LSAT score. Do you see the conclusion here? If you don't, pause your video and take another look. Okay, the conclusion in this paragraph is right here. Time spent practicing LSAT questions is thus time well spent. The conclusion doesn't have to be anywhere in particular in the text. It can be the first sentence, it can be the last sentence, or it can be anything in between. The key is understanding the difference between the logical sequence and the sequence of the text. And that's what we saw here. Luckily, there's a little bit of a trick that you can use to help you better understand the logical sequence of statements. You can use what we're going to call the SO test. Now, the SO test works like this. You put the word so between any two statements, and that should give you a sense of the logical sequence that holds between them. When sentences are in logical sequence, the so should make sense, right? And the so is what can fit naturally between premises and conclusions. Let's try it out here. Let's take a look at any of the other statements compared to the conclusion and put so in between them. Here you go. Your score could earn you tens or even hundreds of thousands of dollars in scholarship money. So, time spent practicing LSAT questions is time well spent. Makes sense? The LSAT is the most important part of your application package for law school. So, time spent practicing LSAT questions is time well spent. See how it sounds natural? It makes sense? One more time. Practicing LSAT questions is an effective way of improving your LSAT score. So, time spent practicing LSAT questions is time well spent. Again, it makes sense. Now let's try it in a way that it doesn't make sense, and you can kind of hear the difference. Let's take the conclusion and put it before something that's actually a premise. Time spent practicing LSAT questions is time well spent. So, the LSAT is the most important part of your application package for law school. What? It doesn't make any sense. It's not the reason why the LSAT is the most important part of your application package. The fact that the LSAT is the most important part of your application package is a reason why time spent practicing for the LSAT is time well spent. When you don't see the conclusion in a paragraph, try using the SO test. It can help you to get a better feel for the logical sequence between statements. In addition to using the SO test, you can also keep an eye out for textual clues, right? Certain words that indicate that a conclusion is coming. Take a look at these examples. Socrates is a man, therefore he is mortal. She's a vegetarian, so she will not eat a cheeseburger. We never lost a game. We are thus the best team in history. I've taken every available LSAT twice. For this reason, You should have faith in my LSAT knowledge. That's true, by the way. And only girls can play here. Consequently, Stephen has to play elsewhere. Keep an eye out for words like this because they indicate conclusions. There are also textual clues for premises or support. Take a look at these. We can't come to the party because we have to take care of our dog. Because you cheated on the test, you get an F. Since you love pizza so much, you should marry it. And I can't play basketball this weekend due to the fact that I hurt my foot. All of these words and phrases indicate that the words after them are premises or bits of support. Now, in more complicated arguments, there are going to be what are called intermediate conclusions. In these arguments, there'll actually be more than one conclusion, although only one of them will be the final or ultimate conclusion, and even the intermediate conclusion will serve as a premise for the final conclusion. So let's take a look here. You should not vote for Johnston. He will not release his tax returns, so it is clear that Johnston is a dishonest person, and one should never vote for a dishonest person. Do you see the two conclusions? Do you know which one is the ultimate final conclusion? Go ahead and pause the video and try to find the logical structure for this argument, including the intermediate conclusion. Alright, let's break it down. There are actually two mini arguments within this very short paragraph. The first one is this. Johnston will not release his tax returns, therefore Johnston is a dishonest person. Right? The fact that he is not releasing his tax returns is serving as support for this conclusion here. Johnston is a dishonest person. Now there's another argument here, and it goes like this. Johnston is a dishonest person. One should never vote for a dishonest person. Therefore, you should not vote for Johnston. Now between the two, do you know which is the ultimate conclusion of the paragraph? Think about it for a second. You can even use the so test. It kind of works here. Try using so in this direction. Start here. You should not vote for Johnston. So, Johnston is a dishonest person. Well, that doesn't sound right. The fact that you shouldn't vote for someone doesn't make that person dishonest. It doesn't really make any sense. However, Johnston is a dishonest person. So, you should not vote for Johnston. There it kind of works. Right? The so test will actually get you all the way to the final conclusion in most cases. But here we can see how there are a number of premises and two conclusions, where one of the conclusions, an intermediate conclusion, actually served as a premise for the ultimate conclusion. In addition to conclusions and premises, every argument also has assumptions. Technically, assumptions are implicit premises, ones that aren't explicitly stated in the text. But let's not worry about that for right now. Let's just call them assumptions. Let's go back and take a look at the argument we just dealt with, or at least the part of it that led to the intermediate conclusion. Johnston will not release his tax returns. Therefore, Johnston is a dishonest person. It's not immediately obvious, actually, that those follow from one another. Yes, in the structure of the argument, the conclusion follows from the support, but that's because the person who wrote this is trying to make a certain kind of argument. In the real world, it's not entirely obvious that Johnston is a dishonest person if he's not releasing his tax returns. What is this argument assuming? Think about it for a second. We can actually put it into words. What this argument is assuming is that the only reason Johnston will not release his tax returns is because he's a dishonest person. And that's not written in the text, but it's an important skill that you have to develop, finding the assumptions that are made in arguments. It's actually a skill that's very often used in philosophy, where you look at an argument that sounds kind of good, you discover the assumptions lying behind it, and you challenge those assumptions. Often, arguments that look kind of okay are actually relying on faulty assumptions. In this case, maybe Johnston can't release his tax returns for some reason or another. Maybe it's extremely complicated, and he thinks that people will misunderstand it, and it'll cause problems for him. No, I don't. Maybe that makes him a dishonest person anyway. But the point is, there are often gaps between the premises and the conclusion, And those are called assumptions. You need to keep them in mind because they're important on the LSAT. Getting into this new logical mindset can take some practice. So let's go ahead and do some practice. I'm going to present a couple examples of blurbs, and I want you to try to find the logical structure within those blurbs. We'll move pretty quickly through them, and the way I want you to do it is to pause your video after I read the blurb, grab a piece of paper, and write down the conclusion first. Remember, you're looking for the conclusion. What is everything leading up to? And then after that, find the support and see how the support relates to the conclusion. Let's get started with the first one. It would cost more to fix your old car than it would to buy a new one. Plus, there's no guarantee that it won't break down again before long. Therefore, you shouldn't get your car fixed. Now, this one's not going to be super tight logically like some of the other ones have been, but I still want you to get in the hang of finding the conclusion, finding the support. Go ahead and pause your video now, and we'll be back in just a second. Alright, I hope you found the conclusion first. It's pretty clearly marked by this textual indicator here, therefore. The conclusion is you shouldn't get your car fixed. Now what leads up to it? Well, the other statements. It would cost more to fix your old car than it would to buy a new one. And there's no guarantee your old car won't break down again. These are both reasons that you shouldn't get your car fixed, right? It would cost more to fix your old car than it would to buy a new one, so you shouldn't get your car fixed. There's no guarantee your old car won't break again, so you shouldn't get your car fixed. See how the so test can work there to make it clear how the relation is between the support and the conclusion? That's the way I want you to see it. Alright, let's do another one. This one's going to be a little bit tighter logically than the last one, but there's a little bit of a twist to it, so let's take a look and then we'll pause your video. Tom is going to be heartbroken tomorrow. If Tom asks Erica out, she will definitely say no. And if Erica says no, Tom will be immediately heartbroken. Yet Tom plans to ask Erica out tomorrow. Poor guy. Alright, pause your video and try to pull a logical structure from this little blurb here. Remember, start with the conclusion. Alright, here comes the conclusion. Tom is going to be heartbroken tomorrow. It's the first sentence in the blurb. Okay, so where did the rest of the blurb fall into it? Well, it must be support. And what do we have here? Tom plans to ask Erica out tomorrow. And if Tom asks Erica out, she'll definitely say no. And if she says no, Tom will be immediately heartbroken. So Tom's going to be heartbroken. Sounds okay. It sounds really natural. But the twist here is that there's actually something missing. It's indicated by this space right here. Do you see what it is? There's no text left, so it can't actually be something that's written in the blurb. But logically, in the logical sequence, something is missing. It's pretty important. If you don't see it, pause and take another look. There's something missing between here and here. Logically, there's a missing link. It's an intermediate conclusion. The fact that Erica will say no tomorrow. That's actually not in the text anywhere, right? If Tom asks Erica out, she will definitely say no. Okay, that gets us really close because we know that Tom does plan to ask her out tomorrow. So if he does ask her out, then she's going to say no. But it doesn't actually say in the text that she'll say no, right? It's there logically. It's almost there on the surface, but you have to see that it's actually an intermediate conclusion. And once we see that, we can see the full logical progression, right? Tom plans to ask Erica out tomorrow. And if he asks her out, she's going to say no. Therefore, she's going to say no tomorrow. If she says no, he's going to be heartbroken. He's going to be heartbroken. Good job if you caught that one. Alright, one more. This one's pretty long. I guess it's a little tricky, but definitely nothing you can't handle. I'm not going to read it. I want to give you the chance to actually just read through it yourself and try to pull out the logical structure. Go ahead and pause your video for this one because I'm going to move on to the logical structure in just a second. Alright, let's get to it. The conclusion of this blurb is this. The Lou sisters are destined for failure with their lemonade stand. Terrible, right? Well, how do we get there? Well, we know because of that storm that many lemon trees were recently destroyed. We also know this conditional here. Whenever many lemon trees are destroyed, the price of lemons rises. So we can conclude from that that the price of lemons is going to rise. Next, we have another conditional. If the Lou sisters have to pay more for lemons, their lemonade stand will fail. Well, the price went up, so they're going to have to pay more, which activates the second part of the conditional. Their lemonade stand will fail. Therefore, their lemonade stand will fail. Now, the stuff down here is actually background information. The Lou sisters recently set up a lemonade stand. There was recently a terrible storm in Florida. It's in there, but it doesn't actually figure into the logical structure of the argument at all. And that's going to be the case in pretty much all of the questions you face on the LSAT. I mean, not all of them. Some of them are straightforward. Every sentence is part of the logical structure, like the examples that we did earlier. But pretty often, the logical structure will be embedded in a paragraph that just has some other information, some background information that doesn't actually bear upon the logic of everything. So keep an eye out for that. Keep an eye out for the sentences that are doing something logically, and be aware that some sentences are just sometimes background information. Now, there are times on the LSAT when you're going to want to know about negation. You're going to want to know how to negate certain statements, right? Usually a statement is made, we take that statement to be true. A negation is when we take I hesitate to say the opposite, because in a second you're going to see why opposite is the wrong way to describe it. It can be a little confusing. But the negated version, the turned off version of the statement, it's when what is said in the statement is not true. So the way that works is we're going to actually use this somewhat strange phrase, it's not the case that. To negate something, I just want you to put it's not the case that in front of it. And I want you to do that instead of just trying to eye it, right? You might just want to eye it, be like, okay, it will rain tomorrow. The negated version, it will not rain tomorrow. And honestly, in that case, it's going to work. And in many cases, it's going to work. But you're going to see in a second that it doesn't work in every case, or it can be a little confusing in some cases. But this here, it's not the case that, that's always going to give you the negated version of a statement. Let's take a look at it here. It's not the case that it will rain tomorrow. Okay. It's not the case that I don't like violence. It's not the case that Mary is a good student. It's not the case that you should make a left at the intersection. Take a look at this one, right? Actually, let's take a look at the one before it too. In either of these cases, suppose you tried to eye it, right? Mary is a good student. What if you went ahead and said Mary's a bad student? That's the opposite. That's the negated version, right? I just kind of eyed it. Mary's a good student. The negation of that is that Mary's not a good student. Mary's a bad student. Well, not quite, right? Because Mary could just be an average student. She doesn't have to be a bad student to be not a good student, right? Literally speaking, the negation of this is not that she's a bad student. It's just that she's not a good one. And that leaves open the possibility that she's an average student or a bad student. Again, here, what if you're like, oh yeah, the opposite of that, you should make a right at the intersection. Well, not necessarily. It's just not the case that you should make a left. Maybe you should go straight. Maybe you should turn around. I don't know. Just don't make a left. But it's not necessarily a right. Now, of course, you could say you should not make a left at the intersection. That might be right. But you can see how kind of trying to eye it, trying to just figure it out on the fly without using it's not the case that, it can sometimes lead you into confusing directions. Again, our proposal represents the best solution. The correct way to negate this is to say it's not the case that our proposal represents the best solution. Because if you just try to eye it, you might say our proposal represents the worst solution, which would be too far, too extreme, right? Just because it's not the case that our proposal represents the best solution, that doesn't mean that it represents the worst solution. It might represent an okay solution. It might represent a pretty good solution, but there's another one that's better. It may represent a pretty bad solution, or it might represent the worst solution. But we don't want to have any of the other of those options as the negation. We just want to say it's not the case that our proposal represents the best solution. Remember that, use it for negation. Negation pops up in many places throughout the LSAT. It's always good to know how the LSAT understands the concept of negation and how you should apply it. There's also a very particular LSAT logic way of dealing with number phrases and words. So take a look at this table here for a few common number phrases or words and what they actually mean on the LSAT. They don't always mean what you might take them to mean in regular speech. It's a very particular technical way of understanding these words, and you need to understand it because it's the way they're used on the LSAT. So let's take a look at one at a time. Many. On the LSAT, many only means more than one. So it's two or more. In regular speech, perhaps you think that many is more than that. Maybe you would never use many for two. But in the LSAT, it's the very particular meaning of the word, and it's only two or more. Same with some, two or more. Same with a few, two or more. Maybe you want to say, no, two is a couple. And anything more than that, three or more is a few. Nope, not on the LSAT. If it's more than one, they can say a few. Just keep that in mind. Now we move on to these other words and phrases that kind of have to do with percentages. Most. Maybe you wouldn't describe some 51% situation as most. Maybe you, in the way you use the word, you reserve the word for, higher percentages than that. This is too close to even. You'd say almost even. It's very technical on the LSAT. 51% is most. Most people say blah, 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 blah. All that means is that 51% or more, all the way up to 100%, that's most. Same with majority of. The majority of is simply 51% or more. And a minority of, correspondingly, is just 49% or less. It can be almost even, but 49% or less, that's a minority. Alright, how about a bit of practice based on what we did in the past two slides? Negation and the special LSAT logic way of dealing with numbers and number phrases. Go ahead and pause the video, and what I want you to do is try to negate each of these statements that involve a number, word, or phrase. So you're going to have to combine your knowledge of negation. Do you remember how we do that? Remember, it's not the case that. So you're going to have to combine your knowledge of negation with your knowledge of the special LSAT logic way of dealing with numbers. And go ahead and give that a shot, and pause your video, and I will reveal the answers in just a second. Okay, let's go ahead and start with the first one. It's not the case that some children dance. That translates to 0 to 1 children dance. Next one. It's not the case that most children play. This one's a little tricky. That translates to a minority of, or exactly half of children play. Remember, if it's not the case that most, 51% or more, that leaves open the possibility that it's exactly 50%, and it also leaves open the possibility that it's 49% or fewer. Okay, it's not the case that many animals communicate. That translates to 0 to 1 animals communicate. And now it's not the case that a minority of politicians are honest. Tricky, this one's like the second one. It translates to a majority of, or exactly half, of politicians are honest. Yeah, right. It's not the case that a few sandwiches remain. 0 to 1 sandwiches remain. And it's not the case that none of the teachers helped. That one translates to at least one teacher helped. So how'd you do? If you had a tough time, take another look, see where you went wrong, see what tripped you up. You can go back in the video a little bit and review negation, or you can refer to this expanded table that lists those same number, words, and phrases, gives their meanings, and gives the falsifier for them. Now for a moment let's talk about conditionals. specifically if-then conditionals. Conditionals have already crept up earlier in this lesson. We've seen them at work, but I want to take a moment and focus on them directly. A conditional is a statement that presents a certain condition for some other thing to happen, right? So in the condition that I lose my job, if that should happen, then, there's an implied then here, then this outcome occurs. If I lose my job, then I will not go on vacation. If I don't have a map, then I will get lost. If you build it, they will come. And in the condition in which you prepare for the LSAT, if you prepare for the LSAT, then you will do well on it. We describe if-then conditionals as presenting sufficient but not necessary conditions for a certain outcome. Now that may be kind of strange language for a lot of people, so let me break it down a little bit. A sufficient condition is a set of circumstances that is good enough to guarantee a certain outcome, right? A set of circumstances that is good enough to guarantee a certain outcome. Let's take a look. In the set of circumstances in which I lose my job, it's guaranteed that I will not go on vacation. In the circumstances in which I don't have a map, anytime I don't have a map, it's guaranteed I will get lost. If you build it in those circumstances, they will come. And in the circumstances in which you prepare for the LSAT, this outcome will come to pass. But the important distinction is between sufficient and necessary conditions. So what that means is that even though these sufficient conditions are circumstances that are good enough to guarantee an outcome, they're not the only way to guarantee that outcome. We don't need it to be that way. We can still get the outcome through other methods or other ways, other routes. Take a look. If I lose my job, I will not go on vacation. Well, according to this statement, the possibility is open that if I don't lose my job, if I keep my job, I still might not go on vacation. And guaranteed if I lose it, I'm definitely not going on vacation. But if I keep it, maybe I just won't go on vacation anyway. Okay? Now, if I don't have a map, I'm going to get lost. But if I do have a map, but I can't read it very well or something, I might still get lost. If you build it, they will come. That's a reference. I'm going to skip that for now. It's a little bit confusing. But so take this one, right? If you prepare for the LSAT, you will do well on it. Well, that's true. I can tell you that. But what if you go there and just by sheer luck, you fill out random bubbles on the LSAT and you get a 180? I mean, look, it's not going to happen. But it could happen. It's possible. And that demonstrates that these sufficient conditions are not necessary. We don't need you to prepare in order to do well. Trust me, it's a way better idea than going in there and filling out random bubbles, but technically speaking, you don't need to prepare to do well. You either have to prepare or be extremely lucky. So the choice is yours. Let's compare if-then conditionals to conditionals that use only. Where if-then conditionals presented sufficient conditions, conditionals that use only present the necessary conditions, but actually not sufficient conditions. Right, so take a look at these. I will attend only if I can afford it. This is a necessary condition for my attendance. Right? I have to be able to afford whatever this event is in order to attend it. If that condition isn't met, I'm not going to be there. It's a necessary condition. But it's not sufficient. Even if I can't afford it, I might not go. It's kind of tricky. You look at it here, it might seem to you upon reading this naturally that this is a sufficient condition, that I will attend if I can afford it. But that's not what this says. It doesn't say I will attend if I can afford it. It says I will attend only if I can afford it. And on the LSAT, you need to understand that statement as presenting a necessary but not sufficient condition. Let's take a look at a second one. Only if enough heat is applied to it does water boil. Okay, where's the necessary condition in this one? Well, it's right here. The necessary condition for water boiling is that enough heat is applied to it. You need this to happen. Water cannot boil unless this necessary condition is in force. It's important that you see the difference between conditionals that say if then and conditionals that use only. If then conditionals present sufficient conditions but not necessary ones. There are other ways of achieving the outcome. And conditionals with only present necessary conditions but conditions that are not sufficient. So we need these things to happen, but they're not enough. Some other things might also need to happen. Okay, but what if we combine them? Conditionals that have if and only if. What do you figure is going on there? Sufficient? Necessary? Think about it for a second. I hope you guessed it. Necessary and sufficient. Okay? So, a person is eligible if and only if she lives in this country. It's pretty straightforward, really. Just kind of take them one at a time. Get rid of this only if for a second. A person is eligible if she lives in this country. So, being in this country is sufficient for eligibility. But, as that stands, we'd say, but it's not necessary. But we have this here. And only if. That adds the necessary condition. So, living in this country is enough, and it's necessary for a person to be eligible. Again, a number is prime if and only if it is only divisible by 1 and itself. This rule about divisibility is enough to define a number as prime, and it's necessary. It's the only way a number can be prime. Necessary and sufficient. Alright, moving right along. There are times in the LSAT when you're going to want to be able to use symbolic logic, which is pretty much what it sounds like. It is something that enables you to reduce large chunks of text into symbols and then to represent the logical structure in that paragraph or that blurb with the symbols. So you're going to have, from big blocks of text, you're going to reduce that to just letters and arrows, where the letters represent certain statements or clauses, and the arrows represent the logical structure. It'll be a lot clearer if I show you. So let's go ahead and revisit a little argument that we dealt with earlier in the lesson about poor Tom, who is going to be heartbroken because of Erica. And let's go ahead and reduce this to symbols using just letters and arrows. Okay, so let's start at the beginning. Tom is going to be heartbroken tomorrow. I'm going to try to choose something from this clause here. It's actually a whole sentence, but I'm going to try to choose something from here that kind of makes it stick out from the other sentences. I'm not going to use Tom here. I don't want to use T for Tom because Tom's in some of the other bits. But heartbroken is its own thing. So I'm going to actually represent this whole bit here. Tom is going to be heartbroken tomorrow as H. H stands for Tom is going to be heartbroken tomorrow. Alright, next bit. If Tom asks Erica out, she will definitely say no. And if Erica says no, Tom will be immediately heartbroken. Now, it's not just about sentences, it's about the logical chunks, right? Hopefully this kind of sticks out to you now, or this makes sense to you now, having gone through most of this lesson. But I'm actually going to represent each of the logical chunks as a symbol. So, for this one, I'm going to use A for asks. So this represents Tom asks Erica out. Next one, she will definitely say no. I'm going to refer to that as N. If Erica says no, that's the same thing, saying no. Tom will be immediately heartbroken. That's back to H. That's the same thing as the first. And this last sentence, yet Tom plans to ask Erica out tomorrow. That's A again. Now this will all be clear once you see it all come together with the arrows. Now let's remember the logical structure, and let's go ahead and write this in symbolic logic form. The first part of the logical structure was if Tom asks Erica out, she will definitely say no. So I'm going to represent that as asks out, then no. Okay, and what this here says, if he asks her out, then she'll say no. And I'm going to actually combine the next part, which would be, it would be something like, if Erica says no, then Tom will be heartbroken. That's the next part logically, but I'm not going to put it here. I'm just going to go ahead and throw that right on here because it follows logically. So far we have, if Tom asks Erica out, she will say no. If she says no, then he'll be heartbroken. And what this here does, Tom plans to ask Erica out tomorrow, that just tells us that, yes, A is happening, right? A occurs, right? It tells us to kind of start this chain going, right? And now look at just this right here. If you didn't even have these words and all you had was this little chain and the knowledge that yes, A is in effect, you could very easily get here without having to go back and work through all the details, right? I tell you if A then N and consequently then H. And then I tell you yes, A is going on. Start the chain. So you say A is going on, okay, we're good to go. That means I can get all the way to H. So from A, I can conclude H. Okay, I know that was a lot. I know it was fast. But don't worry, we're going to have plenty of more opportunities for practice. This time, I'm going to have you try it. This blurb is a little bit more straightforward than the other one. So we'll take a step back, make it a little bit easier. The textual sequence here mirrors the logical sequence, so you don't have to kind of like figure out where everything goes. It's just straightforward. Logical sequence and textual sequence are the same. The only thing that is a little tricky about this one, it's not that tricky, it just requires a little bit of instruction, is that when a statement says not, right, and it's here, the mayor will not make his big speech, I want you to represent that not separately from the letters and the arrows. So let's take a random example. If the sentence was, the birds will not fly south for the winter, I don't want you to represent that as F for will not fly south for the winter, right? What I want you to do instead is have F stand for the birds will fly south for the winter, and I want you to put this symbol in front of it. It's a negation symbol. So this means not F. And don't worry, we'll go over this in some practice sessions in a little bit, but you're going to have to use this negation symbol when you translate this blurb into its symbolic form. Okay? So just remember that, and I'll go ahead and pause the video now, and you take out a piece of paper. You don't want to just do this in your head. Take out a piece of paper and a pen or pencil and take a look at this blurb, write down the symbolic form of it by giving each logical chunk a letter and then using arrows to represent the logical relation between the symbols. Alright, let's take it slowly and we'll take it in turn. Remember, each logical chunk is going to get its own symbol. Let's start with the first one. If it rains in Philadelphia. I'm not going to use P here because we have the parade involved, and I think it'll be easier if we just use R for rain. So this R means it rains in Philadelphia. The next chunk, the parade will be canceled. I'm going to say that is C for canceled. If the parade is canceled, okay, that's the same thing. Canceled. The mayor will not Remember, not make his big speech. So I'm going to have S mean the mayor will make his big speech, and I'm going to negate it. It's not the case that the mayor will make his big speech. And if the mayor does not make his big speech, okay, if not S, he will not be reelected. Okay, another not. So we already have an R, so I can't use reelected, but I'll use E. It's close enough. E is for reelected, and it's a not. Okay, now let's put this in order. If it rains in Philadelphia, the parade will be canceled. Okay, that's R and then C. If R, then C. If C, then not S. Okay, so I can keep the chain going. C, then not S. And if not S, then not E. Okay, so what that tells us is actually, if it rains in Philadelphia, the mayor will not be reelected, right? It shows us the whole logical chain, and it does it in far fewer letters than it's done in the paragraph, right? Look how much shorter and easier to digest this is here than this whole thing here. And yeah, it's a little confusing at first, understanding which bits get their own symbols. Should I use not? Of course, when to use not, and linking the various conditionals together. But this is a skill you're going to practice, and it's become second nature to you. And then you're going to be able to take certain arguments. Not all of them are great candidates, and you're not going to do this even most of the time. But there are certain times, certain arguments, and all the time, pretty much in the logic games sections. That's the analytical reasoning section. But those certain times you're going to want to use symbolic logic to boil things down to a simpler symbolic form. Let's try another one, and this time introduce a couple of new elements. So now we're going to talk about conjunctions and disjunctions, which are just fancy names for statements that use and, that's conjunctions, and statements that use or, those are disjunctions. And we're going to put in new symbols for each of these kinds of statements, right? So when we see and, we're going to use this statement, kind of looks like an A. And when we see or, we're going to use this statement, which doesn't look like an O or an or anything, but it is the disjunction statement. So let's now take these new elements and add them to what we've already got and try to reduce this little blurb here into symbolic form. If it is a sunny day and he has enough time, Sam will walk to school. Alright, let's make, if it's a sunny day is S, and I'm not going to put the conjunction or disjunction bits here. That's only when we actually write down the symbolic form down here. But for now we're just doing logical chunks. It's a sunny day, S. He has enough time. Let's make that T. Sam will walk to school. Let's make that W. If he walks to school, that's the W again. He'll walk with either Bart or Alex. Okay, let's just give them the letters for their names. And let's go ahead and put this into symbolic form. Okay, if it's a sunny day and he has enough time, then, right, the implied then, Sam will walk to school. If he walks to school, then he'll walk with either Bart or Alex. Okay, there we have it. If S and T, then W, and if W, then B or A. If it's a sunny day and he has enough time, then Sam will walk, and if he walks, it will be with either Bart or Alex. Okay, one more thing, and then I promise we are going to get to some practice. But first we have to talk about contrapositives. Because contrapositives are pretty cool, actually. This is really where logic starts to work for you. And I mean, I guess it's been working for us the whole time, making things easier to follow, helping us to understand the logical structure of things. But here's where we can actually learn more than what is written on the page, as long as we understand the underlying logical structure. Okay, so let's take a look at this one here. If it is snowing, Jamal is happy. Okay, pretty simple stuff, right? This is a sufficient condition for Jamal to be happy, right? We know this is a circumstance, the snow. This is a circumstance that guarantees this result, right? If it is snowing, then we know Jamal is happy. Now, can you take anything else from this statement? Is there anything extra that you can learn from this statement? What if I told you that Jamal is not happy right now? How about then? Could you find anything new from this statement? I hope you guessed it. We would know that it's not snowing, because this is sufficient to guarantee this result. And if this result isn't happening, we know that this isn't happening either, because this automatically leads to this, right? So let's write this out in symbolic form. Let's have S for snowing and H for happy, right? And this will say, if it is snowing, then Jamal is happy. Now, what we know, the new bit that we know, and this is the contrapositive, if Jamal is not happy, we're guaranteed to know that it's not snowing out, because the snowing would automatically trigger Jamal being happy, right? And this right here, this second bit, is the contrapositive of this statement here. If Jamal's not happy, then it's not snowing is the contrapositive of if it's snowing, Jamal is happy. And that's new information, right? That tells us something about a new situation that's not even dealt with over here. It tells us about the situation where Jamal's not happy, right? So if we know for some reason or another that Jamal's not happy, we know something else about the weather, right? And that's new information because we understand the underlying logical structure and we know what a contrapositive is. So how did I get this? A little bit of a formula here. You negate what's on the right side of the arrow and bring it on over to the left. You negate what's on the left side of the arrow and you bring it on over to the right. Right? So here it was happy, move it on over, not happy. Here it was snowing, move it on over, not snowing. And that is how you get the contrapositives. Don't worry, we're going to deal with quite a few more of them when we practice, which is right now. This will be the first of a few slides in which you'll get the chance to practice all this symbolic logic stuff we've been talking about. Negation, conjunctions and disjunctions, contrapositives, the whole thing. And what the exercise is going to be is you'll go ahead and take a look at these statements. And what I want you to do is I want you to write the symbolic form of the statement here. And then I want you to move from that symbolic form to the contrapositive, written also in symbolic form. And then I want you to say out loud to yourself the contrapositive in regular text. Okay, so take the statement, write it in symbolic form, write the contrapositive in symbolic form, say the contrapositive out loud. I'll do the first one with you only because we didn't yet represent only if in symbolic form, and I want to show you how to do those necessary conditions because they're kind of interesting, kind of different. And after that, I will set you on your way to do the other ones. So let's take a look at this first one. Daniel will come to the party only if Katie does. This is a necessary condition, a conditional that uses only if. And what's the necessary condition? Well, the condition is that Katie has to go to this party or Daniel's not going to, right? It's necessary for Katie to come to the party for Daniel to come also. So, how am I going to represent this symbolically? Well, think about what we actually know here. We can make a little if-then statement out of this only if. We know that if Daniel's at this party, what? Think about it. Katie must also be at this party because she's a necessary condition for him being at this party. If Daniel's there, Katie's gotta be there because that was a necessary thing. Daniel was never going to go unless Katie was there. So as soon as we see Daniel, we know Katie is somewhere at that party also. Okay, let's move to the contrapositive. If we don't see Katie, right, this is negating the right side of the arrow, well, Daniel must not be there either. And this is negating the left side over there and bringing it over here. If Katie's not at this party, then Daniel is not at this party either. That's the contrapositive. And again, I'll say it out loud so we have the full exercise. Here's the statement. Daniel will come to the party only if Katie does. It's represented as if D, then K. The contrapositive is if not K, then not D. And this statement, spoken aloud, is if Katie does not come to the party, then Daniel will not come to the party either. Okay, now I'm going to set you on your way. Go ahead and pause your video. Again, don't do this out loud. Do this on a piece of paper. It's much better for you to write down the symbolic forms to have that practice on the page. So grab a piece of paper, pen, pencil, and write out the symbolic form of the statement, the contrapositive, and then go ahead and say the contrapositive out loud. And then I will be back to give you the answers in just a few moments. Alright, here we go. Every time a bell rings, an angel gets its wings. This is just an if-then statement. If a bell rings, then an angel gets its wings. So we represent that. It's B for bell, W for wings. Every time a bell rings, an angel gets its wings. The contrapositive, if an angel is not getting its wings, well, there must have been no bell. And again, remember how I did that. Just took the right side of the arrow, negated it, brought it over to the left. Took the left side, negated it, brought it over to the right. If an animal is a mammal, it does not lay eggs. We have a little negation here, remember? Hope you caught that. So let's go with M for mammal. If an animal is a mammal, then no eggs. Okay, now when we make the contrapositive here, remember the first step is to negate what's on the right side of the arrow. But there's already a negation here. What are we going to do? Well, you know that just kind of like in math, two negatives makes a positive. It's the same in logic. If it's does not lay eggs, that's the same as laying eggs. Right? So if it's not, it's not the case that it's not the case that the animal's laying eggs. That is the same thing as just a regular old E here. So we don't need to put the double negations. Okay, so when we negate this for the contrapositive, we're just saying that if an animal lays eggs, must not be a mammal. And that's the negation of this over here. The last one, for all you Pink Floyd fans, if you don't eat your meat, you can't have your pudding. Two negations. If you don't eat your meat, no pudding. But if I see you eating pudding, I know you must have eaten your meat. Okay? Hope you did well on this. If not, we've got a little more practice going. You can also just rewind the video a little bit and try this again. Erase this right off the screen and try this again. But now we're moving on to a bit more practice. These ones are a little more complicated, so take it slow. Just focus on each logical chunk. Remember what we talked about in the lesson so far, and see what you can do. Go ahead and pause your video. I'll be back in just a moment. All right. If either Cassie or Penelope quits, the band will disperse. Okay, we have a little disjunction here. And let's see how we represent this. Let's go with C for Cassie quits. Now we have our disjunction, or P for Penelope quits. Then, so if Cassie quits or Penelope quits, then we'll put a D for the band disperses. All right, now we have to do the contrapositive. It's a little tricky. We haven't done a contrapositive where one of the sides of the if-then was a disjunction. So let's see what we can do. At least we know this part here, it's pretty easy. We know that we're going to learn something new if the band didn't disperse. But what is it we learn? Let's go back and look. Well, either if Cassie quit or if Penelope quit, either one of them alone was sufficient to trigger the dispersing of the band. So if the band didn't disperse, then neither one of these things must have happened. And we can represent that this way. We can say that if the band didn't disperse, then we know that Cassie didn't quit, and we also know that Penelope didn't quit, right? Because either one would have been enough. Okay, so your contrapositive becomes if the band did not disperse, or will not disperse, then Cassie didn't quit, and Penelope didn't quit. All right, moving on. Every time it snows, both Pablo and Mark can be found at the library. Okay, so we have an if-then statement here, and we have a conjunction in the then portion of it. So every time it snows, let's go with an S for snow. If it snows, then have P for Pablo is at the library, conjunction, and we'll have an M for Mark is at the library. And now another tricky contrapositive, because we have to negate this conjunction right here. So how do we negate a conjunction? So here we have Pablo and Mark are at the library. So what does it mean to say it's not the case that Pablo and Mark are at the library? Now, if you're being too hasty, you might say that nobody's at the library. Pablo's not there and Mark's not there. But that's not quite right, right? It actually is, all we're saying is that it's not the case that both of them are there, which means neither one of them might be there. But also, if just one of them's not there, this is still negated. So what we need to put here is, if no Pablo, or no Mark. If Pablo's not at the library, or if Mark's not at the library. And an important thing to note here, on the LSAT, the disjunction is what's called inclusive. It could be and. So this means and or, actually, right? Not P, or not M, or not both is actually what that means. But anyway, if Pablo's not at the library, or Mark's not at the library, again, or both, then it must not be snowing. And the last one. If dogs and cats are both present, either Jan or Kyle will supervise. All right, we have a conjunction in the beginning, and we have a disjunction in the end. Let's see what we can do. So let's have D for dogs being present, and cats being present. So if dogs are present and cats are present, then either Jan or Kyle will supervise. So I have a J for Jan will supervise, or Kyle will supervise. If dogs and cats are both present, then either Jan or Kyle will supervise. Okay, contrapositive with a disjunction on one side and a conjunction on another. Very complicated stuff. Okay. what we need to say first is that neither one of these things happen. Remember, it's kind of like this one up here. So if no j and no k, because what we're saying here is we're learning something new if this part isn't going on. If we don't have Jan and we don't have Kyle. So if we don't have Jan and we don't have Kyle, what do we know? Well, we know that dogs, it's not the case that dogs and cats are both present. And now we're going to start to represent it like this one. Either dogs are not present, or cats are not present. And remember, it's inclusive, so maybe both are not present. So, the contrapositive. If both Jan and Kyle do not supervise, then either dogs are not present or cats are not present. Okay, I hope you did well with these. These were a little tough. And we're moving right along. Don't worry if these are really tough. We just introduced you to these topics, and now I'm hitting you with pretty difficult problems here. These are probably more difficult than most of what you're going to see on the LSAT. But I just feel like it's important to stretch you here, to make you do more difficult ones, so that when you see the ones on the LSAT, they're easy for you. But I want you to have the opportunity to try difficult ones to really build this skill, and do not worry if it's tough. Go back, watch again, try them tomorrow, try them until you get them. Try writing your own, and then doing the contrapositives and the symbolic logic from there. These are all ways of building a very important skill. But don't worry if you don't have that skill just yet. Stick to it. Okay, so this time we're introducing some of those number words and phrases. It's really going to make things much more complicated. So same exercise though. Reduce the written statement into symbolic logic, and then write the contrapositive, and then say the contrapositive out loud. That's going to be the tricky part here in this one, because when you say the contrapositive out loud, you're going to need to remember how to falsify or negate the number words and phrases. So again, take your time, break down each logical chunk, try to remember how these number words and phrases work on the LSAT, and do your best. Go ahead and pause your video, and I'll be right back. Alright, let's dig in. If the news is on, most people will be paying attention. Okay, so the first part's pretty easy. If the news is on, then most people will be paying attention. I'll call it A for attention. If the news, then attention. Very good. Contrapositive. Okay, here's where it gets tricky. If it's not the case that most people will be paying attention, then the news must not be on. But now let's think about those numbers. If it's not the case that most people will be paying attention, what does that mean? Well, it means that if 50% exactly or fewer, right? If exactly half or a minority of people will be paying attention, then the news must not be on. That's how we read if it's not the case that most people blah blah blah. Remember, because we have to use the falsifier for most, which is exactly 50 or a minority, 49% or minus. If the mayor enacts this policy, some people will protest. Okay, so we'll have E for enact. If he enacts the policy, then some people will protest. If it's not the case that some people protest, well, he must not have enacted that policy. But again, we need to go and look at this number. If it's not the case that some people will protest, or some people have protested, how do we make sense of that, thinking about the numbers? Well, what are the cases in which this is going on? Well, either one person is protesting or 0 people are protesting, because it's 2 plus. So if nobody's protesting or just one person is protesting, then we know that the mayor didn't enact the policy, because we need 2 plus. If many people attend the party, we will need to hire a server. Okay, so let's put attendance. If many people attend, then we have to hire a server. If many people attend, then we hire a server. If we don't need to hire a server, this is a little silly, but how are we going to put this? It's not the case that many people attended the party. And how do we read that? It's not the case that many people attend the party. Well, that means that either one person attended the party or nobody attended the party, because all we need to say many is 2 plus. So 2 plus didn't happen. That leaves 1 or 0. If nobody helps, I'm going to quit. I'm sure we have all felt that way before somewhere. Let's say H for helps. If nobody helps, I'm going to quit. But if I don't end up quitting, what does that mean? It means it's not the case that nobody helped. Or more naturally, at least one person helped to block this part of the condition, right? If I didn't quit, at least one person helped. Again, I'm sure that was really tricky. It was tricky for me putting it here right now. But again, if you didn't get it, go back, try it again, or give yourself a little break and try it again later. Or go back in the video and look at that table again to remember what the falsifiers are or the negators are for these number words and phrases. Alright, one more. And this one's a little bit different. We're going to skip the text part. I've already given you symbolic logic here. So you're going to take the symbolic logic and just give us the contrapositive and then say the contrapositive out loud. But of course you're going to be talking about variables. You're going to be saying x and y instead of whatever x and y stand for. So pause your video and try to get this one done. I'll be back in just a second. Okay, here we go. So what does this say? If x, then y. Okay, and to get the contrapositive, we have to negate the right side, bring it to the left. If no y, and then we negate the left side, bring it to the right. Then no x. And saying it all together, if no y, then no x. Next one. If no d, then r. Okay, well the contrapositive, if no r, and now we have that double negation again. So we just get rid of the negation. If no r, then it must be d. If no r, then d. Here we go. If m and s, then f. Contrapositive, if there's no f, then there is either no m or no s or both. Inclusive disjunction. If b or l, then z. So if no z, then no b, and no L. Oh boy, look at this one. If x and y and z, then c and d. Alright? So, if no c or no d, or both. Then, now we gotta translate this one. Then it must be the case that one of these is missing. No x or no y or no z. And I made a little mistake there by saying one of them is missing, because it might be that one's missing, it might be that both are missing, or it might be that all three are missing, because right, we have the inclusive disjunctions. So if no c or no d, then no x or no y or no z or a combination. And the last one, if p or q, then no a and e. All right. So how do we negate this part here? We're going to have to turn a conjunction into a disjunction, because that's what we've been doing so far. So if either a, because that negates the first part, or negate the second part, no e, then now we have to negate this other bit, turning a disjunction into a conjunction. No p and no q. If a or no e, then no p and no q. All right. Give yourself a real pat on the back if you were able to get through this one. And generally speaking, congratulations for even trying these. Like I said, these were tough. They increased in difficulty as we went on, but I wanted you to have a chance to deal with some difficult practice. I really think that the ones that are on this page especially, and some of the other ones, they are harder than anything you're going to see on the LSAT. So go back tomorrow or at a later time and try this practice again. Keep coming back to this until you can do this. It feels so intuitive, so natural. And again, make your own. Keep practicing. Make sure this is second nature, and it will really, really give you an advantage when you're taking the LSAT. You don't want to be figuring this out on the LSAT. You want to just have this skill ready to go. Alright, that is it for the basics of LSAT logic. That was a dense lesson for sure. We went all the way from an introduction to what logic is at the most fundamental level, all the way to symbolic logic and contrapositives, all kinds of crazy stuff. Congratulations on getting through. This is definitely a lesson that it makes sense to go back and watch again. I think you'll be extremely and pleasantly surprised at how natural everything feels after you've gone through it once with some difficulty, and then sleep on it or whatever, come back tomorrow and review this. The concepts will be familiar, and you'll have a much easier time with things. Try that practice again after you've gone through the video again. So definitely one worth repeating. And next time we will be talking about logical reasoning, not as a concept like we were doing now. We'll be talking about the logical reasoning section of the LSAT, which is where a lot of this stuff really gets applied. So I look forward to seeing you there. Thanks a lot.